Hi everybody again. This is John Walker, your science teacher. This is the second part in the introduction to chemical reactions. So I just read you a paragraph and we went through just a little bit of chemical reaction, and which we had a chemical formula, and we had some reactants, and those came together with some energy and they made products, and we went through that. So let me go ahead and scroll down here and cover the second part of this. So we went through this, didn't we? Okay, and hopefully you got this, but I'm gonna sort of think, so this whole thing here is an equation, isn't it? Okay, so this stuff equals or yields this stuff over here. So you have two hydrogen atoms, okay, and actually come together, and then you have two of those, and they come to, and then they unite with two oxygen atoms, and they make two, okay, molecules of water, don't they? Okay, so this is the second part of this one, introduction into chemical reaction. So can you do this matching? Okay, so match the word to the definition and then write the letter on the line. Pretty easy to do. So product. So let's go down. Let's say a combination of symbols. So what's a product? Okay, so what is a product? Okay, is it a combination of symbols that show the redo of elements in a compound? Okay. What is a coefficient? What is a chemical equation? Okay, so there's all these different ones down here. Okay, a reactant, a chemical change, precipitate, okay, endothermic reaction, chemical formula, subscript, endothermic reaction, chemical symbol, law of conservation of mass. And so, law of conservation of mass, we should know that, right? We've already given all that stuff. Okay, wait a minute, here it is right there, huh? Principle that states that matter is not created or destroyed during a chemical reaction. Okay, so we would know that. So you'd have to go through here and do that. Now I'm going to give you the answers to this, in another video a little bit later. But I want you to go through and see whether or not you can go ahead and find the answers on this. Balancing chemical equations. Now, remember that matter cannot be created nor destroyed, so whatever we have on this side, okay, the reactant side, has to equal the same on the product side. So here we have to have this is a coefficient here, okay, another coefficient, okay, so this stuff, okay, yields, that arrow sign says yields, or I'll sometimes always think in my mind that it's equals, okay, and then Si, okay, how many of those, and then how many of chlorines, okay, and once again here's another reactants to products. So, and this is a good way actually to go ahead and write these things out in a formula type situation. So here you have coefficients here, and this would be a coefficient here, and this sign is a yields, right? And how many of those would that be? And then what I want you to do is I'd like to have you go ahead and put together your multiple choice. Which of the following statements is true about a balanced chemical equation? Okay, reactants are on the right. No, reactants are on the left. Subscripts can be changed. No, they can't. Products are on the left. Nope, products are on the right. Okay, the total number of atoms are equal on both sides. Yep, got to have the same. We can't create nor destroy, mass. And then over here at 29, which of the following equations is properly balanced? And I'll let you work that one through. Okay, and so that's the second half of this in terms of all the information and data that we have taken a look at in terms of chemical reactions. And I'll talk to you soon, okay? So do that. I am going to have the answers, but first of all, I want you to work through that and see whether or not you're okay with the knowledge that you're getting at this time. Stay safe.